Morning all. Welcome to the course on mechanical measurement, third semester, mechanical engineering polytechnic students. And my name is Satish, a lecturer from Government Polytechnic, Bagalkot. Today I'm going to give a lecture on Unit 1 measuring instruments, and the topics covered in today's class are, so what do you mean by a measurement? Methods of measurement, and what is the significance of measurement? Terms used in measurement. So all these four topics are going to covered in today's class. So in day-to-day activities, we come across a measurement. Generally, we are going to weigh our weight of our body. We are going to purchase some materials from the stores, and all these physical variables are going to convert it into numericals. So daily we are going to measure nowadays the corona is there, the temperature we are going to measure. All this temperature is converted into numerical value. This temperature is a physical variable and it is going to be converted into a numerical value. In day, generally we are going to discuss about mechanical properties only. I'm not going for electrical properties because this subject is especially for mechanical students, and I'm going to take the examples of mechanical properties only. So in generally day-to-day activities, we are going to measure the length of a table, length of a distance between 2 points. All this we are going to measure, and length is a physical variable that is going to convert it into a numerical. Width is a physical variable and we are going to convert it into a numerical variable. Length we are going to convert it into a physical unit called as meters. Similarly, temperature we are going to convert it into degree Celsius or Fahrenheit. Like that, we are going to convert it into every properties into a physical variable into an numerical value, and we are going to assign a numerical value of a specific numerical value so that that becomes a standard. For example, distance we are going to measure in meters, length we are going to measure in meters, speed we are going to measure in meter per second, mass we are going to measure in kg. So like that, stress Newton per meter square, velocity meter per second, all these things we are going to measure velocity meter per second, and volume meter cube, quantity we are going to measure pressure pascals, amount of substance, speed, mass in kg, length is in meters. So all these things, distance is also in meters. All these things we are going to measure a physical variable into a numerical value. So that physical variable is converted into a numerical value, and we are going to assign a numerical value of specific numerical value. So this specific numerical value is accepted by all. That becomes a standard. So there are generally in SI units there are 7 basic units are there. Length we are going to measure in meters. Length we are going to measure in meters, and mass we are going to measure in kg. Time is in seconds. Electric current in amperes, and temperature in Kelvin or degree Celsius. Luminous intensity in candela. Amount of substance in mole. So these are the basic fundamental units for measuring any type of physical variable. There are many derived units from the from the basic units. Those are called as derived units. So for example, area is measured in meter square, volume in meter cube, speed meter per second, acceleration meter per second square, force in Newton, energy joules, power watt. So these are all the derived units. Still some two are there, the supplementary units are there, so that you can discuss in some other class. So we come across all this. So measurement means we want to compare a quantity with some known standard. A measurement of a given quantity is essentially an act or result of comparison between a quantity whose magnitude is known with a similar quantity whose magnitude is known, whose similar quantity is magnitude is unknown. The later quantity is being called as a standard. So you can see from the figure that this is a process of comparison what we are going to do. So let us take this figure. So let us take an example of I'm going to measure weight of a human body. So that is called as a comparison. So to measure the weight of a human body, I'm going to stand on the weighing scale, and this is human body, and the result will be the numerical value. So this is the physical variable, and this is compared with using an instrument weighing scale. The weighing scale is calibrated with a standard, and this standard is known as known quantity. Known quantity, and this human body is a physical variable, is an unknown quantity. And both this known quantity and unknown quantity is a comparison is called as what? Measurement. The measurement of a given quantity. Given quantity is what? The human body is the given quantity, is essentially an act or result of a comparison between a quantity whose magnitude is unknown. This human body is a magnitude. This quantity, how much the weight is there, we don't know that one. With a similar quantity whose magnitude is known. That means this standard is a magnitude of a known quantity. We are going to compare with the unknown quantity with the known quantity, and this known quantity is called as what? Standard. And this process is called as what? Measurement. This process is called as what? Measurement. The measurement of a given quantity is essentially an act or result of a comparison between a quantity whose magnitude is unknown with a similar quantity whose magnitude is known, the later quantity being called a standard. So there are two types of measurement. One is direct comparison, another one is indirect comparison. In direct comparison, we are going to compare an unknown magnitude with directly with the primary or the secondary standard. For example, measuring the length of book, length of table. That means we are going to use the scale for the measurement directly. That means this physical variable is directly measured by using a standard, that is maybe it's a primary standard, secondary standard, or working standard, and is compared with the unknown variable. That process is called as what? Direct comparison. Here lots of errors are going to be occurred in direct comparison. Maybe the human errors are more in direct comparison because the physical involvement of a human is there in the direct comparison. If you come for the indirect comparison, there are number of quantities that cannot be measured directly. For example, if I want to measure the force is in what? Newton. The unit of force is what? Newton. We can't measure directly the force unit. that is equal to force is equal to mass into acceleration. We can measure the mass directly. We can't measure the mass acceleration directly. And the combination of this mass and acceleration is the Newton. How to measure this Newton? How to measure this force? So generally for this kind of measurement we are going to go for indirect comparison. Hence, the indirect comparison method of measurement is made by comparing unknown magnitude with the standard through a calibrated system. So generally, we are going to indirect comparison method is very much used in nowadays because compared to direct comparison is accurate and human involvement is less. That means the errors are less compared to the direct comparison. So let us compare the direct and indirect comparison. So in direct comparison, an unknown quantity is directly compared with primary or secondary standards. Primary or secondary standards. But if you go for in direct and indirect comparison, an unknown magnitude is measured comparing with the standard indirectly. The very important thing is what we are going to compare it with indirectly through the use of a calibrated system. So through the use of a calibrated system, we are going to compare it. So human sensors are very much necessary for measurement. So generally we are going to use the scale for measurement here. To measure the length of any physical variable, we are going to use the scale. That means human sensors are very much necessary here. That means the view sight of a person to person is going to be varied. That means errors are more over here. So in indirect comparison consists of chain of devices which form a measuring system. That means we are going to use transducers, we are going to use sensors, we are going to use sensors over here, sensors, transducers, all will come to the picture over here. The results obtained from direct comparison are not dependable. Results what we are going to obtain from direct comparison are not dependable. That means, for example, if I want to measure the temperature of a human body, this is going to be a result, and there is no feedback from here to the input. This is what a feedback. Feedback is not available from the input. Here the feedback is necessary. Feedback is must, where in indirect comparison it is not dependable. Directly you can directly measure by using the scale, but here the sensors senses the physical variable and sends the signal. Then it transducer converts the one form of signal to another form of signal. Then amplification takes place. Then the results will appear. This consists of a detector, that is nothing but sensor, a transducer which converts one form of a signal to another form of a signal, and to indicate or record the processed signal. This consists of what? Sensors, transducers. For all this purpose, there is chain of devices are going to be appear in indirect comparison. So in direct comparison, it is not always accurate. Accurate is not possible, but it is fairly accurate. Indirect comparison is fairly accurate. It is good over here compared to that one. So we'll move for the next topic. What is the significance of measuring instruments? Why we need a measurement? Is it necessary for measurement is there? Imagine if a person is not going to measure, is it able to purchase something? Is it possible to measure the temperature without using the instruments? If we measure the temperature without using instruments, that means it will affect the quality of the person's, quality of the health of a human body. So that a measurement needed for ensuring public health and human safety. So measurement is needed for public health and human safety. Industrial measurements proper control and accuracy of measurements so as to ensure interchangeability with a view of to promoting mass production. Because in a car manufacturing company, there are thousands of parts are available in a car manufacturing company. So all the parts are not going to be manufactured in the same company. Each part is going to be manufactured or supplied by suppliers or vendors. That means, and finally, all these parts are going to be assembled in a company who is going to be promoted to the market. So that every part which is coming from all the suppliers are bound to interchangeability. That means one part should match with the other part. For example, in interchangeability, imagine for example, in interchangeability, imagine the same part, the same part is supplied by two vendors. One part is inserting to the assembly part. The supplier who is supplied from the supplier 2 is not inserting into the assembly part. At that time, the interchangeability is not holds good. When it happens, when the measurement is not proper. If the measurements are accurate, if the measurements are precision, if the measurements are bound to some tolerance, at that time, if any number of suppliers are there for the same product, then those parts are matched with the interchangeability. That means we can pick any part from any supplier so that we can assemble into the assembled part. So this helps in mass production. So this is the importance of measurement, significance of measurement. If there is no measurement, proper measurement is not there, then it is highly difficult for mass production. Proper and economical design of equipment process and also proper operation, control and maintenance of industrial process require a feedback of information, and this information can only be provided through measurements. To reduce the cost, processed with maximum efficiency and reliability. So to reduce the cost, by using measurements, we can reduce the cost. Measurements are included with advancement of science and technology, new phenomena and relationships are discovered, and these advances make a new type of measurements imperative. So that means usually nowadays the measurements are more accurate, more precision. That means due to advancement of technology, nowadays indirect measurements are more important than direct measurements due to advancement in the technology. That means the sensors are available, strain gauges are available. Every minute change in strain, every minute change in stress, every minute change in length, we can measure. All these are important. All these are the importance of measurement. We'll move for the next topic. What do you mean by a true value? A true value of a quantity to be measured may be defined as the average of infinite number of measured values when an average deviation due to the various contributing factors tends to 0. That means if I'm going to measure the weight of, I'm going to measure the weight of a laptop. Weight of a laptop. At first instance, the weight of laptop is 3.5 kg. At second instance, the weight of laptop is 3.55 kg. At third instance, the weight of laptop is 3.54 kg. So like that, I am going to measure n number of times. After measuring n number of times, I'm going to add all these things: 5, 4, 9, 5, carry 1, 3, 6, 9, 10. That is 10.59 divided by 3. So we will get 10.59 divided by 3, we will get some average of 3.53. So this is the average mass of the laptop, average mass of the laptop. Is there any deviation between the first instance and the second instance? First instance and the second instance? Yes, sir, definitely there is a deviation between the first instance and the second instance. That is 3.5 minus 3.55. That means that the deviation is how much? 0.55 deviation is there. If this deviation is 0, if this deviation is 0, then your standard and true value are same. Your standard and true value are same. So this, it is impossible to measure this true value in practice, and hence it is not possible to determine the true value. So the true value of a quantity to be measured may be defined as the average of an infinite number of measured values when the average deviation due to the various contributing factors tends to 0. So I have one standard. How they are going to make the standard? They are going to measure infinite number of times. They are going to measure infinite number of times, and that average deviation will be 0. That average deviation will be 0. For example, they are going to make a, so now we know that 1 meter is equal to a light traveled in some seconds. That is seconds is there. That is the distance traveled by a light. So this measurement, practical measurement is made n number of times, infinite number of times, so that 1 meter is equal to some value. First instance, 1 meter is equal to some value. Second instance, all these instances will be same. If the instances will be same, then they are going to make it as a standard. And we are always comparing this standard with the unknown quantity. And this process is called as what? Comparison. After comparing this unknown quantity with the standard, we'll get one number. That number is called as what? A result. So this process is called as what? Measurement. This process is called as what? Measurement. After we got the result, this result is same as standard, then it's called as what? True value. Then it's called as what? Yes, I got the true value. That is, true value is nothing but what? Actual value. Actual value is nothing but measured value. So true value is nothing but what? A standard. So the true value of a quantity to be measured may be defined as the average of an infinite number of measured values and the average deviation due to various contributing factors tends to a 0. Such an ideal situation is impossible to realize in practice, and hence it is not possible to determine the true value. So we will go by one. What are the various terminologies we are going to use in measurements? So accuracy. So what do you mean by an accuracy? So we studied about a true value. True value is nothing but what? We are going to measure infinite number of times, and if the average deviation is 0, and that is called as what? True value. And true value is difficult to measure practically. So accuracy means, let us see this figure. So this is a yellow line. You can observe this one. You can observe the center point is yellow, and there is one circle over there. Next one is a red circle. Next one is blue circle, and the finally it is a black circle. So all the three arrows are hitting on the black circle. My target is what? A yellow circle. My target is what? A yellow circle, and this yellow circle is what? A true value. That yellow circle is what? A true values. Let us take this is the true value. True value, and my aim is what? I want to hit all the arrows to the center of the circle, that is on the yellow circle, but the arrows where it has dropped on the black circle. So this indicates that accuracy is very low. Accuracy is very low, but always it is hitting on the black circle, that is called as what? It has high precision. But that means a person who is hitting the arrows always hitting on the black circle, that means he is hitting the first arrow is also on the black circle, the second arrow is also on the black circle, and third arrow is also on the black circle. That means he is first time hit on the black circle, second time is also hit on the black circle, third time is also hit on the black circle. That means the consistency is there in the measurement. Every time when he is dropping the arrow, every time he is dropping on the black circle, that means he has the consistency. That indicates, that means the measurement made by every time is in consistency. There is no much variation between the measurements at every time what he is doing. In the second figure, we can observe that one. All the times the arrows are hit on the red circle. Red circle. But the arrows are not close to each other. This arrow is, that means there is a difference between these two arrows. That means there is a difference between these two arrows. There is a gap between these two arrows. So it indicates that we have low precision. There is no consistency. ಒಂದು ಪಕ್ಕ ಒಂದೊಂದು ಬೀಳ್ತಾ ಇಲ್ಲ, arrows ಪಕ್ಕ ಪಕ್ಕನೆ ಬರ್ತಾ ಇಲ್ಲ. So that there is no precision over here. But accuracy is what? Yes, it is near to the true value. This is true value. Arrows are near to the true value. Here the arrows are far from the true value. Here arrows are near to the true value. That means accuracy is a medium. Accuracy is what? Medium accuracy is there. That means when the arrows coming closer to the true value, when the measurement is closer to the true value, that indicates the accuracy is increasing. But arrows are, the distance between the arrows are far, that indicates what? Low precision. Here in the come to the third figure, all the three arrows are close to each other. The distance between the two arrows are all close to each other, and all three arrows are in yellow circle. That indicates all are in the true value. That means high accuracy and high precision. So by seeing this figure, we can define that accuracy means when the measurement is close to the true value, then accuracy is more. Accuracy is the closeness with which the readings of an instrument approaches the true values of the quantity measured. Thus, accuracy measurement means conformity to the true value. So when the accuracy measurement means conformity to the true value, closeness to the true value, that indicates what? Accuracy. Precision describes the spread of these measurements when repeated. A measurement that has high precision has good repeatability. When we do the n number of measurements, when we are going to do n number of measurements, when we are going to do 10 measurements, imagine we are going to measure 10 times. 10 times the length of a board. Every time we get 2 meters, 2.10, 2.13, 2.14, second, third 2.01, 2.02, that means it has a low precision. Low precision. The same board is measured 2 meters, 2, 2, 2, 2, 2.01, 2.001. That means it has a high precision. That means if any times I am going to measure, the same readings are going to appear. That is called as what? Precision. Maybe this reading is not true, nearer to the true value, but the instrument is a precision instrument. So we will move for the next slide. Accuracy is about how close measurements are to the true answer. Precision is about how close measurements are to one another. So next term is the repeatability. Repeatability is the closeness of agreement between repeated measurements of the same thing carried out in the same place by the same person on the same equipment in the same way at similar times. That means every time, if by using the same measurement equipment, the same at the same place, at the same temperature, at the same way, and the same method of measurement, we are getting the same readings, then we are going to call it as what? Repeatability. So reproducibility is the closeness of agreement between measurement of the same thing carried out in different circumstances, example by a different persons. That means the measurement is done by a different person at different time, at a different method, so that if it gets the same reading, then we are going to call it as what? Reproducibility. Repeatability and reproducibility, don't get confused. Both will get the same result, but in repeatability, at same person, same equipment, same methodology is going to follow to get the results. If those results are closeness in the agreement between each other, then we are going to call it as what? Repeatability. Sensitivity. The sensitivity of the instrument, it is the ratio of the magnitude of the output response to the magnitude of the input, that is quantity being measured. That is called as what? Sensitivity. So you can observe in the voltmeter, if I pass a current to the voltmeter, it will indicate some movement in the needle. That is called whatever the input what I am going to give, some output is going to be obtained. So that for a very small change in input, there will be an output. That is called as what? Sensitivity. Every instrument should be sensitive to the physical variable and insensitive to the other variables. That is very important. So we'll move for the next term, that is calibration. Calibration is the comparison of a test instrument or artifact against a more accurate standard. That means every instrument we are going to compare with its higher standard. So we are going to use the working standards. Generally in shop floors we are going to use working standards. That is, working standard is compared with the second master working standard. So this is the measuring equipment we are going to use in shop floor. So here shop floor equipment is compared with the lab working standard. The lab working standard is compared with the secondary working standard, and secondary working standard is compared with the primary working standard. So by comparing this one, if there is any mismatch between the primary standard and the secondary standard, and the secondary standard and the master working standard, and master working standard and the measuring working standard, if that is going to be calibrated by you by adjustments, by inputting some other values, all those things are going to done is called as what? Calibration. Calibration is a comparison of a test instrument or artifact against a more accurate standard. So that means primary standard is more accurate compared to the secondary standard. Secondary standard is more accurate compared to the working standard. And working standard is more master working standard, that is lab equipments. And that standard is more accurate than the shop floor equipments. So a calibration applies a known input value to a measurement system for the purpose of observing the system output value. How to calibrate? That means if I want to calibrate a scale, I want to calibrate a scale which is in the shop floor. So that means that is, imagine it's a weighing scale. I want to calibrate it. How to calibrate it? I'm going to bring a standard, that is lab standard 1 kg of standard physical variable, and that is going to put on the weighing scale. If it shows 1 kg, then that equipment is right. At every time, I am going to measure n number of times. N number of times also it should indicate 1 kg only. For first time it indicates 1 kg, and second time it indicates 1.1 kg, means there is no repeatability. Repeatability is not there. That means we want to calibrate it. Some of the parts are not working. There will be a backlash, there will be hysteresis, there will be a friction. All those things are going to occur, or wear and tear will happen. So that is going to be calibrated. All these things comes under a picture of calibration. So next one is a range. It represents the lowest and highest possible value that can be measured by an instrument. For this one, you can take an example of, so let us take a voltmeter example. So this is a indication from 0 to 30 volts. This is 5 volts. This is 10. This is 15, and this 20, 25. So there will be a reading like arrow. So voltmeter. Let us take this as a voltmeter. So range, it represents the lowest and highest possible value that can be measured by the instrument. So in this voltmeter, how much we can measure? We can measure up to 30 volts. We can measure up to 30 volts we can measure. This is the range of the instrument, is how much? 0 to 30 volts. We can measure from 0 volts to 30 volts. If I want to measure 5 volts, is it possible from this instrument? Yes, it is possible from this instrument. We can measure 10 volts in this instrument. Yes, we can measure 10 volts from this instrument. That means that this is the range of the instrument we can measure. So, and one more important thing we want to consider in the range of the instrument. For example, 0 to 30 volts. If I want to measure 5 volts every time, is it okay for this? Is it okay to choose this instrument? No, this is not okay. While choosing an instrument, the range 0 to 30 volts range, that means our values should fall in the 60% range. 60% range. That means 30 volts. 60% means how much? That means 15 is 50, around 20, around 80, somewhere here. If we want to measure, that means 10 to 25, that is okay for this instrument. So it represents the lowest and highest possible value that can be measured by the instrument. That means 0 to 30 volts is the range of the instrument. So next comes under threshold. If the instrument input is increased very gradually from 0, there will be some minimal value below which no output change can be detected. Take the same example of a voltmeter. I am going to pass the current, so the needle will be 0 only. So forget about, we'll take one more example, weighing scale. So this is the weighing scale. This is 1 kg standard I have put it here, and this is a stone of 1 kg. Now I am going to put the physical variable of 1 gram. How much? 1 gram over here. Does it indicate anything over here? There is no change. I am going to put 2 gram, no change. 3 gram, no change. 10 gram, no change. I'm going to put 25 gram. At that time, it will starts indicating some change. It starts indicating some change. So the needle starts indicating. That means the reading starts giving. Up to 25 gram, there is no change. Up to 25 gram, there is no change of a reading. That gap is called as what? Threshold. If the instrument input is increased very gradually from zero, zero ಇಂದ ನಾನು ಏನು ಮಾಡ್ತೇನೆ ಇನ್ಪುಟ್ ನ ಏನು ಕೊಡ್ತಾ ಹೋಗ್ತೀನಿ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಾರ್ಟ್ ಗಿವಿಂಗ್ ದ ಇನ್ಪುಟ್ ಸ್ಲೋಲಿ ನಿಧಾನ ಕೊಡ್ತಾ ಹೋಗ್ತಾ ಇದ್ದೀನಿ there will be some minimum value below which no output change can be detected. That means 25 gram ಇಂದ ಕೆಳಗಡೆ ನೀನು ಎಷ್ಟೇ ಹಾಕಿದ್ರು ಔಟ್ಪುಟ್ ಅದು ತೋರಿಸ್ತಾನೆ ಇಲ್ಲ. It indicates that means the threshold value is there. This threshold value is of different reasons, maybe due to friction, maybe due to hysteresis, maybe due to wear and tear, maybe due to backlash. For all other things, there will be a threshold will be there. If you want to measure 1 gram, is it possible from this weighing scale? Yes, it is possible, but you want to take the range. Range is different. That means now I have taken 0 to 1 kg of 0 to 1 kg of scale. This is the range of the scale I have purchased. If I want to measure 1 gram from this scale, is not possible because the range is more. If I want to measure 1 gram, that means I want to purchase 0 to 100 gram or 0 to 25 gram scale. The range should be very much less. Then I can measure 1 gram. From this scale, I can't measure 0.01 gram. If I want to measure 0.01 gram, again I want to purchase a small scale of 0 to 0.1 gram scale. The range should be 0 to 0.1 gram of scale. Then I can measure 0.01 gram. So because the choosing the instrument is also an important thing. The range is important because the threshold will be there. So we'll move for the next slide. Hysteresis. What do you mean by an hysteresis? Hysteresis is a phenomena which depicts different output effects when loading and unloading, whether it is a mechanical system or an electrical system. So you take one example of here, rubber. I am going to apply the force on the extension. I'm going to imagine I'm going to apply a force of 5 Newton. There will be extension of some here. I'm going to apply 10 Newton. There will be extension up to here for 10 Newton. There for 15 Newton there will be an extension up to here. For 20 Newton there will be an extension up to here. Okay. After extension, again I want to release the loads. Now I come to 15 Newton. It come over here. Again I come for the 10 Newton. It came over here. Again for the 5 Newton, it came over here. That means while loading, it follows the different path. While unloading, it follows the different path. For the same input, the input is how much? Same. But the outputs are, for the same input, there are two outputs. For the same input, there are two outputs. For the same input, there are two outputs. That means the extension is same. The output, the input is what? 5 Newton, 5 Newton, 10 Newton, 10 Newton, 15 Newton, 15 Newton, 20 Newton, 20 Newton. But the following path is what? Different. The following path is what? Different. So similarly, we can observe in resistance as well as in temperature. You can observe this also. That means this is a positive and this is also negative. That means for the same value we are going to apply from 0 to positive values as well as negative values, you will get this kind of a figure. So stress is a phenomena which depicts different output effects when loading and unloading, whether it is a mechanical system or an electrical system. Hysteresis is a non-coincidence of loading and unloading curves. So why it has happened? ಯಾಕಾಗುತ್ತೆ ಇದು? Hysteresis arise because of mechanical friction, magnetic effects, elastic deformation or thermal effects. For all these reasons, hysteresis will take place. So this is because of second law of thermodynamics. That means second law of thermodynamics, what it states, no process is irreversible ಮಾಡೋಕ್ಕೆ ಆಗಲ್ಲ. Next will come, this is for all today. We'll come to the next session in the coming class. Thank you.